Assalamu alaikum. Hello everyone. I am Ala Tanash, a PhD student at University Malaysia Bahar. I am here today to present my research work under the title Effect of Ceramic Tile Powder as a Partial Cement Replacement Material in the Mortar. We start with the presentation outline. In the beginning, we start with the introduction. After that, the problem statement, objectives of our study, result and discussion, and then conclusion of our study. At the end, the references. Let's start with the introduction. The United Nations has introduced the Sustainable Development Goals for global sustainable and inclusive development. One of the Sustainable Development Goals focuses on combating climate change and purposes and green transformation in all sectors of economy. Concrete, the most widely used building material, has significant environmental impacts such as high energy consumption and carbon dioxide emission. In the end, to align with the Sustainable Development Goals and mitigate the impact of concrete on climate change, alternative cement material should be utilized. On the other hand, ceramic products such as tile and sanitary ware are crucial components in construction. The global production of ceramic tile exceeded 12.6 billion square meters in 2019. Approximately 30% of ceramic production worldwide is disposed of in landfill annually. Ceramic waste, also from construction sector, consists about 45% of construction and demolition waste. Recent research has shown that broken ceramic tiles can be used as substitute for certain types of cement in concrete. Incorporating ceramic tile waste into concrete not only offers a waste management solution, but also help conserve resources by reducing the dependency on the natural resource. Now the problem statement. First problem we have construction and demolition waste and impact to nature. The construction and demolition waste is produced mainly during the building rehabilitation and demolition phase. The generation of waste construction and demolition activity continue to escalate globally as the construction industry is also expanding. Therefore, construction and demolition waste is becoming a major problem to threaten the long-term sustainability of a global economy. Here in the pictures, we see some of the environmental impacts of construction demolition waste. First of all, landfill demolition, water pollution, and air pollution. The second problem statement for our study, cement production, impact to nature. The cement industry contributes mainly to carbon dioxide emission, which is considered the third emitter sector in the world. After that, energy consumption. Also, the production of cement consumes a lot of energy. It's an intensive process for energy. This will be also pollute the environment and, on the other hand, consuming non-renewable resources. Also, air pollution and land degradation. Now, objective of the study. Determine the effects of ceramic tile powder as a partial cement replacement on the workability of mortar. The second objective, to determine the effects of ceramic tile powder as a partial cement replacement in the compressive strength of the mortar. At the end, the third objective, to determine the effect of ceramic tile powder as a cement replacement in water absorption of the mortar. Now, experimental program. Here we shows the mixing ingredient. First of all, cement. We use ordinary Portland cement for our research. Second, the sand. River sand has been used as a fine aggregate. Ceramic tile powder. Ceramic tile powder as a partial cement replacement with 10 and 20 and 30, 40 up to 50% replacement to cement. At the end, the water, also tap water and the clean water was used in this study. Okay, testing and code practices. The first test, the flow table test. A flow table test was used to determine the mortar workability. The workability of mortar using a flow table test in accordance with ASTM C 1437 section 15. Another test, the second test, is the compressive strength test. To obtain the compressive strength and maximum loading of the mortar with various percentage of ceramic tile powder. The test was carried out in accordance with ASTM C10911. The third test and the last test, water absorption. To obtain the water absorption of mortar with various percentage of ceramic tile powder. The water absorption test had been carried out according to BS 1881-122. Now the result and discussion. First of all, the workability. Here in the figure, we can show the flow behavior of mortar. So the flow behavior of mortar, based in the figure, decreases with increasing proportion of CTB as a partial cement replacement, reaching up to 150 millimeter at 50% replacement. This behavior could be due to non-uniform morphology of CTB, which could increase interlocking and thus friction between particles, as well as the energy required to stand the mixer to flow. The second test we have here, compressive strength test. First of all, we can see in the figure the compressive strength of test with various percentage of ceramic tile powder content. We can see from the figure that with compressive strength decrease with an increasing the proportion of ceramic tile powder. The 28 days compressive strength range from 2937 megapascal to 52.5 megapascal. At 50, then the lower compressive strength at 50% of ceramic tile powder. We can see up to replacement more than 20%. The compressive strength decreased significantly. This mainly due to dilution effects of cement and also the low pozzolanic reactivity of ceramic tile powder due to particle size higher than the median particle size of ceramic tile powder used in this study, higher than cement. The second, strength activity index. We can see from the figure the strength activity index of the mortar with various percentage of CTB content. The test results showed that the addition of CTB affects the compressive strength of mortar at an early age, with this proportional to the amount of CTB. This mainly due to no pozzolanic effects of ceramic tile at early age. At CTB content of up to 10%, the strength activity index of mortar with CTB is still more than 75% according to the requirement of ASTM 6108. However, the proportion of up to 50%, the strength index dropped to 40%. The lower development of a primary calcium silicate hydrate structure in the matrix is held responsible for this performance, especially at replacement higher than 20%. Mortars with 20% CTB had 92 strength at 28 days, while 20% ceramic tile powder had 88% of strength, both exceeding the ASTM minimum 75%. In the end, the water absorption. We can see in the figure the effects of ceramic tile powder and the water absorption of the mortar. Based in the figure, blend with 10 and 20% CTB show similar water absorption to control sample. Blend with over 30% cement replacement exhibit higher water absorption. This is because to reduce hydration product increasing and mortar porosity. At the end, conclusion. Using up to 20% of CTB, cement treatment powder as a cement replacement result in mortar with comparable strength to control mortar. Excessive use of CTB should be avoided as it leads to a significant decline in strength. Integrating ceramic tile powder as a partial cement replacement in construction material production has the potential to reduce the use of cement and decrease the amount of ceramic tile waste ending up in landfill. This approach would contribute to sustainability, effort and waste reduction in the construction industry. Now the references used in this study. This slide shows the references used in this study and the presentation. Thank you all.